Hello and welcome back to Mr. Gallant's sixth grade robotics class. Um, I've really been enjoying seeing kind of some of the programs y'all created from the previous day. And I will continue to enjoy seeing the programs that you're making. So yesterday we talked about Bob. And Bob, we programmed with LEDs to make him dance back and forth. So that was by doing zeros and nines and stuff like that. Now, I kind of said it a couple of times. You might have heard it, but you created an image using binary. And that's what we're going to talk about today is we're going to do some understanding of what binary is. So if you're looking at the screen, you will kind of see how binary is set up. Now, usually binary with computers, especially since we're dealing with the Microbit, which only has 5 lights, we are dealing with 5 or base 10 5-digit numbers. So we have the first spot, the second spot, the third spot, the fourth spot, and the fifth spot. Now, the first spot is actually referred to as 2 to the power of 0. Now, this is an 8th grade skill, so I don't expect you to know that, so I'm giving you the cheat sheet. But 2 to the power of 0 is equal to 1. And then this spot is 2 to the power of 1. Again, I don't expect you to know that. That is actually going to be equal to 2. And then we have 2 to the power of 2, and that's equal to 4. This is 2 to the power of 3, which is equal to 8, and 2 to the power of 4, which is equal to 16. I'm not expecting you to know that. What I'm expecting you to understand is how binary works using these numbers that you see at the top of the screen here. Basically, what you're going to do is you're going to use zeros and ones. 0 means off, 1 means on. 0 means off, 1 means on. Now, if at any point in this video you're confused, feel free to pause, rewind, go back and watch it another time, okay? I want you to make sure you fully understand binary because by the end of our lesson here, you're going to make a binary counter on your microbit. We're going to program it to do that, and it will actually display a binary counter on the screen. It's kind of cool. Okay, so here we go. Now, if I want to make the number 1, I need to add up these numbers on top to make the number 1. Well, that's easy. I just need the number 1 right here. So 16 is off. I don't need the number 16. 8 is off. I don't need the number 8. 4 is off. I don't need the number 4. 2 is off. I don't need the number 2. But I do need the number 1, and that gives me 1. So binary for 1 is 0, 0, 0, 0, 1. Okay. Now 31 is the largest number I can make with 5 binary digits. That's by turning on everything. I need this on, this on, this on, this on, this on, or 1, 1, 1, 1, 1. And I add up all the numbers. 16 plus 8 plus 4 plus 2 plus 1 is going to give me 31. Okay. That's the biggest number I can make with a 5-digit number, a 5-digit binary number. If I wanted to make a number bigger than 31, I need to make a 6-digit binary number, that would be 32 would be the next number that I could start using. However, we're not worrying about a 6-digit binary number. We're only working about a 5-digit binary number. So if I have everything turned off, so that's 0, 0, 0, 0, 0, or in binary 0, 0, 0, 0, 0, that's going to give me a value of 0. Everything's off. If I do 0, 0, 1, 1, 0, that means the 4 place is on, the 2 place is on, so 4 plus 2 is going to give me 6, okay? So let's kind of work on this a little bit. Let's see what numbers we can make. I have some binary kind of here waiting for me. Now, if we want to make the number 0, what numbers do I need to add together to make 0? None of them. What that means is every number will be turned off, okay? So that 0 will be turned off. That 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 will be turned off. Oops. I appreciate y'all being patient with me. and that will be turned off. So that is how I get the number 0. Everything's turned off. Now let's go look at number 3. I'm going to look at how to make the number 3. Well, which of these numbers do I need to add together to get 3? There's only one way to do that, and that's going to be 2 plus 1. Okay, so I'm going to take the 0 right here. If I'm making 3, the first number is going to be a 0 because I don't need 16. The next number is going to be 0 because I don't need 8. The next number is going to be a 0 because I don't need 4. And these are a little off. There, I guess I can make this look a little bit easier for y'all. But y'all are smart kids. Y'all are probably getting it pretty quick. There, a little bit easier, right? Okay. Okay. Now I need the 2 in order to make 3. So I'm going to take this 1 right here. And I need that 1. And I also need this on. Now, because of that, that means I have 2 added to my binary, and 2 and 1 are both turned on, okay? So basically, I turned this one on, which gave me a value of 2. I've turned this one on, which gave me a value of 1. So 2 plus 1 is going to give me 3, okay? Let's do another number. Let's say I wanted to do the number. That's a great idea. Let's do the number. No, let's do 21. Okay, we're gonna do the number 21. Okay, so what numbers do we need to add together to get to 21? Now, first of all, do we need 16? Yes, we're gonna need 16. Okay, oops. Don't know what I just did. But I'm going to bring this 1. I'm going to, it wants to be difficult. There we go. I'm going to put this 1 right here because I need 16. So 21 minus 16, 16, 17, 18, 19, 20, 21. It means I have 5 left. I need 5 more because I just turned this spot on. Okay, so I need 5 more in order to get to 21. Okay, well, how do I make 5? 5 is going to be 4, and it's going to be 1. Okay, that's how I make 5. It's just being fun, guys. I'm sorry. So, of course, if I was doing this on a screen, it'd be so much easier, like on my smart board over there. Okay, so I've turned on these spots. So this spot is equal to 16. Okay, this spot right here is equal to 4. And this spot right here is equal to 1. Okay, now, so 16 plus 4 is 20. 20 plus 1 is 1. So that gives me my value that I'm looking for, which is 21. Okay, now, of course, this binary number is not over because I have these blanks here. Well, what goes in the blanks? Zeros do, because I don't need those ports to be turned on, so they are turned off. Okay, now you can make any number you want using binary. Okay, and what we're going to be doing today is we're going to be writing a program for our microbit to count binary for us. Okay, so if you're not already there, you can go on the Green Acres website, scroll all the way down to the bottom, and find Python for Microbit. Fun times. Okay. Okay, so have my microbit plugged in. Just a quick reminder, anything after the hashtag is a note. So I'm going to make my note binary counter. Line number 2 says from microbit import asterisk. Basically, that's making sure that my microbit and my computer are speaking the same language. We don't want one speaking one language and the other one speaking a completely different language, okay? And then we have while true. That means it's going to repeat this program over and over and over again. Now, what I'm going to do is I'm going to go to line 4. And what I'm going to do is I'm going to create what's called a variable. Now, if I ask you 2 plus x equals 3, and I asked you what does x equal, you would know, oh, x equals 1 because 2 plus 1 equals 3, okay? We use variables in robotics and programming also. So usually a variable takes the place of something in the program. So our variable for this program is going to be bin capital COUNTER, bin counter or binary counter. And we want to set our binary counter to 0. And I'm going to add a note here just so I know what I'm doing. That means starts our counter at 0, okay? We don't want to start our counter at 7. We want our counter to start at 0. So every time our program runs, it will always start at 0, okay? Now, everything after while true, I'm going to delete. I'm going to keep while true. Now, remember, I don't have to keep it as while true. I could do 2 greater than 1 because 2 is always greater than 1. But for programming purposes, I'm going to keep it at true. TRUE with a capital T. Now, remember, if I'm going too fast, pause the video and do your program, okay? So yesterday, you worked on using buttons in your program. So we're going to do that again. We're going to do if button, if I can spell button, underscore a period is underscore pressed. Crab face, colon. Okay. Now what this means is if I press the A button. Now remember, you don't have to add the notes. I'm adding the notes to help me know what everything is. And what I wanted to do is I wanted to do a bin counter. Now notice that it indented over here. So bin counter is going to equal whatever the bin counter was before plus 1. Okay, so if I press the A button, it's going to add 1 every single time I press the A button. So if we start off at 0 and I press the A button once, it's now going to be 1. And if I press the A button again, it's going to be 2, 3, 4, 5, 6, 7, 8, 9, 10, da 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 da. Okay, then I want it to sleep for half a second. Now, the reason I want it to sleep after pressing the A button is because, remember, your microbit thinks faster than you do. So we have to slow our microbit down. If you press the A button, it's going to read it every millisecond, which means it's going to count extremely fast before you have the chance in order to actually count 1 at a time. So we're going to make it pause half a second after you press the A button each time. So you can go 1, 2, 3, 4, 5, rather than 6 billion. Okay. Now we have our A button done. So now we're going to do else if button underscore B period is underscore pressed crab face colon. So that'd be if I press the B button. I'm going to have my little note here. This is to add 1. Okay. Now, if the A button adds 1, guess what the B button's going to do? That's right, multiply. No, I'm kidding. Subtract by 1. So I'm going to do bin counter. Now, notice how I'm keeping bin counter exactly the same with a capital C. Bin counter is equal to whatever the bin counter was before minus 1. So it's going to subtract 1. Okay. And then again, I want it to sleep for half a second. Now, when we're doing our counter, remember we said there's only 5 spots available on the microbit. So we want it to only count up to the largest number that 5 binary digits can count to. And if you remember, The largest number that all the binaries can count to is 31, okay? Which means when we're counting with the microbit, if it ever goes above 31, our microbit can't handle it. So what we're going to do is we're going to set a roof on our microbit, okay? And we're going to say, okay, else if bin counter ever gets greater than 31, okay, colon. So that means if I get above, not 2, but if I get above 31, I hit that roof. Now I could just stop there, or I can go all the way back to 0 and start again, hit that roof, go back to 0 and start again. So that's what I'm going to do. I'm going to have it set or go back to 0. I'll say, okay, if it gets above 31, I want it to do bin counter equal 0. Okay, so it resets the binary counter. Okay, so we have a program here. We have it to where I press the A button, it's going to count by 1. If I press the B button, it's going to subtract by 1. If I ever get to 31, it goes back to 0. Okay, now here's the problem though. My microbit is now counting. So if I connect this, I download the program, putting my batteries in so I can show y'all. So I had a successful download. Now I'm going to hold this up to you. Okay. Now nothing is appearing on the screen because the number is supposed to start at 0, and 0 means everything off. Now when I press A, nothing happens, but something is happening. The microbit is counting. It is counting. It's adding, it's subtracting, adding, subtracting, adding, subtracting. The problem is we didn't tell the microbit to show anything when it was adding and subtracting. So that is going to be what we need to add to our microbit next. Excuse me. So I'm currently on line 13. I am going to line up with my else if. So notice how I'm still indented. Okay, I'm going to scroll up a little bit, down a little bit. Okay, I'm still lined up with my else if. I'm not all the way back here, but I am on line 15. And I'm going to make a new variable. So remember, our first variable was bin counter. Now we have our second variable. And this one will be binary version visual number, binary visual number, or BVNum, okay? And this is going to be equal to whatever my bin counter is, okay? So if my bin counter is 1, my binary vision number, or BVNum, is 1. If my binary counter is 31, my BVNUM will be 31. So I made those two things equal, okay? Basically what this is doing is a placeholder for the binary number, okay? I'm going to hit enter twice. I am now sitting on line 17, okay? So if my BVN can be divided by 16, okay? That means that 16 can evenly go into it, and that answer is greater than or equal to 1. So what that means is that 16 can go into my number. Then what I want it to do is I want it to display dot set dot set underscore pixel 0, 2, 9. Okay. Now what that means is, I just made it mad. This is the left side. This is the right side. That means if 16 can go into it, it's going to light up this light right here, all the way over here on the left-hand side of my microbit, okay? So if 16 can go into it, I want it to light up the furthest light on the left, okay? Now, I then wanted to do BVNUM is equal to BVNUM minus 16, because I just said 16 can go into it. So I'm going to subtract 16 from it to get my new number. Now, if 16 cannot go into that number, so if I choose the number 7, 16 cannot easily go into 7. So I want else. I want it to display dot set underscore pixel 0, 2, 0. And what that means is that spot will be turned off if 16 can't go into it. So if I give you the number 18, can 16 go into 18? Yes, it can go in there one time. So that means that light will be on. If I give you the number 2, can 16 go into the number 2? No, so that means that light will be off. Okay, so now we're going to do the next problem. The next part of the program. So the first part was 16. Guess what we're going to do now? The number 8. Okay, so I'm going to say if BVNUM, my binary divided by 8, is greater than or equal to 1, that means that 8 can go into my number. Scroll down so you can see what I'm doing. I want it to display dot set underscore pixel. Please make sure you're doing pixel, P-I-X-E-L, because students sometimes have a habit of typing the word pickle. And I'm not kidding, they really do. And I want to do 1, 2, 9. So basically what that means, I'm going to unplug it again, I'm going to make it mad. It's going to be the second light will turn on. And I want to do BVNUM equals BVNUM minus 8. Okay, so if I give you, let's go ahead and finish this program and then I'll do my example. Else, that means if 8 cannot go into it, I want it to display dot set underscore pixel 1, 2, 0. Okay, I want that light to be off. Okay, so if I give you the number 10, okay, I give you the number 10. Can 16 go into 10? No. So the first light on the left will be turned off. Okay. Can 8 go into 10? Yes. Okay, so that means the second light will be turned on, and then it'll do 10 minus 8, which is 2. Okay, and then it's going to turn on that light. Now, we did 16, we did 8, so the next one will be 4. Now, you can retype all this if you want, but what I'm going to do is I'm going to highlight all of this, go to line 29, and hit paste. Okay, but I'm going to change my numbers. That one will be changed to 4. That will be changed to 4. And I want the next light to turn on, so that goes to a 2. Here I want to change that to 4, and here I want to change that to 2. Okay, so I've moved one light over. Okay, so now I have the first 3 lights being used. If 4 can go into it after 16 and 8 have already gone into it, because it reads it from the top to the bottom. If it can still go into it, it will light it up. Okay, so I'm going to highlight all of this because we're not done, because we did 4, now we have to do 2. So I'm now on line 35. I'm going to hit paste. And of course, I want to do 2. So 2, 2, 3, 2, 3. Okay, so now I have the next light. After 2, the next number is 1. So we're going to make sure we do our 1 number. So I'm now on line 41. And I want 1, 1, 4, 1, 4. Okay, so let's do a number. I'm going to do it on pink paper. And let's say I give you the number 28. Okay, I'm giving you the number 28. Okay, now I'm going to start off with 16. Okay, here I do my. So this is 16. This is 8. This is 4. This is 2. This is 1. Okay, so I have my binary down here at the bottom. Okay, so I'm starting off with 28. Can 16 go into 28? Yes, it can, because 28 is larger than 16. So I'm going to do a 1 above the 16 here. This marker is actually bad. Let me switch markers. Okay, so I did a 1 above the 16, and then my program does 28 minus 16, which is 12. Okay, so now it's done my program for 16. Now it's going to go into 8. Can 8 go into 12? Yes, it can. That means my 8 spot is turned on. I subtract by 8, okay, and I get 4. Okay, so now I've done 16, I've done 8, now I'm going to do 4. Okay, can 4 go into 4? Yes. Goes there one time, so there's a 1 above the 4. And then I do 4 minus 4, and now I get 0. Okay, so now I have 2 left. Can 2 go into 0? Nope. So I put a 0. Can 1 go into 0? Nope. I put a 0. So that means my binary number for 28 is 11100. Okay, let me do another one. Okay, let's do an odd number. Let's do 25. Okay, so I'm going to do my 16 place, my 8 place, my 4 place, my 2 place, and my 1 place. Okay, so I have my binary spots down here. Now, first of all, can 16 go into 25? Yes, 25 is bigger than 16, so I want a 1 there. Okay, so now I'm going to subtract. My program has it subtract. 25 minus 16. And I get 9. Okay, now, so I move on to the next number. Can 8 go into 9? Yes. So I turn on my 8 spot, and then my program does 9 minus 8, and I get 1. Okay, so now it's the 4's turn. Can 4 go into 1? No, it cannot. So the 4 places off. Okay, now I'm at the 2 spot. Can 2 go into 1? No. The 2 spot is now off. Can 1 go into 1? Yes. So the 1 spot is on. And now I do 1 minus 1, and I get 0. So I'm done. So the binary number for 25 is 11001. Okay, and our microbit is now doing that for us. Okay, so I'm going to plug my microbit in. Okay, it's connected. I'm going to do connect. Awesome, it's connected. And I'm going to flash the program there to make sure there's no line errors. Awesome, there's no line errors. Got angry. Okay, so my microbit starts off as blank. There's a reason it's starting off as blank, because it's at 0. 0 means everything's off. Okay, but if I press 1, the 1's place lights up. Now, if I press it again, 1 plus 1 is 2, and binary for 2 is the second light. And then 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. All the lights are lit up. Now, according to my program, what should happen when I press the A button again? That's right. It's going to go back to 0. And everything turns off, which means it went back to 0. Now, the A button is addition. So 1, 2, 3, 4, 5. But if I press the B button, it's subtraction. 5, 4, 3, 2, 1. Okay, so I have my binary counter. Okay, so which means, and then I can press the reset button. So let's say I count a whole bunch of times. Oops, went subtraction. I'm going to count a whole bunch of times. Okay, so here's a binary number. So I'm going to pull out my pink paper here. And what I have is off, on, off, on, off. Okay, so there is my binary number. So I'm going to do my values. That's 16, 8, 4, 2, 1. Okay, 16 is off, 4 is off, 0 or 1 is off. So that means 8 plus 2, which is 10, which means this binary number right here that it's showing on my screen is 10. Now, if I wanted to go back to 0, I could hit the B button 10 times and it will go back to 0. I can hit the A button 21 times and it'll go back to 0. Or there's a little button on the back, and if I press that little button on the back, it resets it back to 0. Okay, so your assignment for this video is I want you to write this whole program, which I'm hoping you did with me. In fact, you should pretty much have it done. I want you to take 2 screenshots of your program, 2 different screenshots. I want to see how your program goes, and I want you to run the program on your Microbit. I want you to count with binary, okay? Try to, if you need to, get a piece of paper. Remember, all of my paper is right here behind my desk. Get a piece of paper, randomly press the A button a couple of times without counting, and then try to figure out what the binary number is, okay? So I'm going to press the A button a couple of times. I'm not counting. I'm paying no attention to what I'm doing, okay? Okay, so I get this number right here, or this binary representation right here. So it is off, on, off, on, off. So off 0, on 1, off 0, on 1, 1. Okay, so that is the binary number right there for these lights. And now I give them their values underneath: 16, 8, 4, 2, 1. Okay, 16 light is off, so I don't use 16. The 4 light is off, so I don't use 4. Now I add up the numbers that are left. 8 plus 2 is 10, plus 1 is 11. So that means 0, 1, 0, 1, 1 is equal to 11. Okay, so by the end of this lesson, I'm hoping that you can count using a 5-digit binary number. Now, again, I could go larger if I wanted to. So let's say I wanted to do a 6-digit number. 6. Okay, I have 6 spaces now. That would mean 1, 2, 4, 8, 16, 32. Okay, and I can keep getting bigger by adding more blanks. The next blank after 32 would be 64. Okay, and I can keep getting bigger. You're kind of seeing what the numbers are doing here. Okay, so I can continue getting bigger and bigger and bigger, but this is how computers think. Okay, it turns stuff on and off using ones and zeros. It takes your analog information. So analog information is information that you understand. My voice right now is analog. You can hear my voice, which means it's analog. However, you cannot hear the Wi-Fi in the room right now. That's digital. Okay, so that is why computers can't think analog. Computers don't have ears. Well, you say, well, they have a microphone. Yes, they do have a microphone, but what a microphone does is it takes our analog information that we're giving and turns it into digital information that the computer can understand. Okay, so I look forward to seeing y'all's programs when you are done. Excuse me. So make sure you turn in 2 screenshots of your program. And if you don't remember how to do a screenshot inside of the Google Classroom, all the way down at the bottom under classwork. Here we go. All the way down here at the bottom, there's computer shortcuts and resources that walks you through how to do a screenshot on a Chromebook, okay? If you have any questions, please put them as private comments inside of the Google Classroom assignment. I'm answering the questions as quickly as I can get them, or as quickly as I get them. So I'm here to help you. Even though I'm not in the classroom, I'm there with you as best as I can be. So please feel free to reach out if you have any questions. So I look forward to seeing your 2 pictures turned in, and I look forward to quizzing you on binary another day. Wahaha. Bye.